Hi, I'm Terry Klinker. We're going to continue our discussion of sensitivity analysis. This session we're going to talk about shadow price. Shadow price has to do with what if we have more resources. All right, we've talked about the fact that our solution is sensitive to how many resources we have. The solution is sensitive to what the inputs are, what assumptions we made. In this case, we've said we have 2,400 hours of carpentry and we have 1,000 hours of paint. If we have 1,000 hours of paint, 2,400 hours of carpentry, and the assumptions on profit margin are the same, we're going to make 320 tables, 360 chairs. And that's going to give us a profit margin of $4,040. You've seen that in several videos before. I won't go back through that. But what we want to find out is, if we have more resources, and most of you will understand this right off the bat, if we have more resources, we can make more money. So the question becomes, what is the value of more resources? To do this, we calculate what's called the shadow price. Now the shadow price is defined as the change in your objective function value at the optimal solution if we increase one constraint by 1 unit. All right. What happens if we increase the constraints? What would happen if I said, instead of, I decide to add one person, I decide to add an entire person to this item. Instead of 2,400 hours, all right, if I had, let's just pretend this is a weekly output. If I had 2,400 work hours available in my carpentry shop and I added one person, this would go to 2,440 hours. Now remember that everywhere along this boundary, this constraint that we put in, everywhere along here, this says that 3 hours per table plus 4 hours per chair equals 2,400 hours. Everywhere along that boundary, 2,400 hours have been consumed. If I add one person, so I now have 40 more hours, that means this line would come out here somewhere. And now this line is 3 hours per table plus 4 hours per chair equals 2,440 hours. Well, look what happens when we do that. All right? First off, my feasible region changes. Now I can produce up into here. Also, this is no longer a corner point. This corner point goes away. The corner point now becomes this spot. So I have a new optimal solution. In theory, hopefully, I can make more money with more resources. The more tables I can make, the more money I can make. All right, we're assuming we can sell everything we make. So it changes everything. Well, the shadow price is, what if I increase it by 1 unit? Well, at 40 units or 100 units or whatever, obviously the line changes way out here. What happens if you increase it by 1 unit? So instead of 2,440, I would have 2,401 hours. Well, even there, that just pushes this boundary out a little ways. Granted, it would be probably too hard to see on this scale, but it would still change that optimal solution somewhere in there. So what we have to do then is we have to figure out where that optimal solution is. All right, let's find out where the new corner point is. So we have 3 things we have to do here. First, we're going to add 1 unit to 1 constraint. In this case, what we did was we said 3 hours for every table plus 4 hours for every chair is going to equal 2,401 hours. We've got 1 more hour. Once we've done that, it now has a new corner point. So now we have to solve for the new corner point. which in this case will give us a new and improved optimal solution. The third step then, we will calculate the new objective function value OFV, objective function value. We'll compare the new one, compare the new objective function value to the original objective function value. The difference between the two is the shadow price. So you got a 5-step process here. In the next video, we will take this out, we will solve this, and show you how it's done.